Nope, wrong, correct. All right, looks good. Hello, everyone. Well, hello, dear patrons. Let's start like that. So, yeah, we're 2 minutes late. We're fine. I'm hoping audio is good. I'm hoping video is good. It looks okay. So, yeah, let's do this. Just to pick up where the post ended on Patreon. I kind of missed out on last month's Q&A Hangout. I'm sorry for that. If you look at my YouTube page, there's not been like a real full video uploaded for way too long. I just had everything at the same time coming in. Whatever. Okay, we're doing a longer one today. Let's do like, I don't know, 45 minutes to an hour. Let's see how many questions we get in. I'll try to answer them all. So I guess let's just jump right in that button. Nope, this one. Oh, that is delicious. Good thing I'm doing this one before I start the God, good thing I'm doing this stream before I do the full stream later today. Capture. Okay, I can't capture this one. Hang on a second. I have to restart OBS Studio. 1 second. Okay. We should be back and screen captured work. Yeah, OBS Studio has this weird thing where if you don't start the OBS Studio window on the same screen or in the same graphics adapter that you want to capture, it can't capture it. I don't know why that's happening, but I've run into that a few times. I'm hoping video is smooth. It is sort of jittery for me. But yeah, this should work now. Yes. Let's actually just jump in right here. June Live Hangout, that is the $5 plus. Yes, that is the premium Patreon post. So let's start with Pink Mouse right here. Let's just start from the bottom and work our way down. If you've got questions, feel free to ask them in chat and I'll try to answer those first. All right. Pink Mouse is asking, I've glossed over the stepper acceleration settings in Marlin for the Dolly i3 clone build. I rushed them in the main video. Yes, I did. But are there ways to optimize these for a particular setup rather than just trial and error methods? So I did make a video about this. It's called something like tuning speeds. You should be able to look that up on my channel. The thing is, tuning acceleration is... I mean, of course, you could do the math. You could do all the measurements. You could do all the math. But 3D printing has never really been about doing the math properly. You know, ever since this entire RepRap thing started, it's not been... By the way, D7, we're unboxing that later. Yes. 3D printing has never been about doing the math and doing it correctly for the most part. So... I mean, the machines aren't even set up for that. We're using like this tiny GT2 or GT3 GT series belt that is basically way too flimsy, so we have to work around with accelerations which aren't like sinusoidal accelerations. There's just linear ramps. There's a huge array of things that is not, you know, if you look at it from an engineering perspective and you do it properly, there are a lot of things that aren't done properly. So tuning accelerations for me has always been like a trial and error. Basically, you look at a print and you look at whether you like it or not. So, for example, this is from the what's it called? The Italian high-speed 3D printer that sort of never, you know, was able to do or to go that high speed because it... Hold on, there we go. Because it was way too floppy on its motion system. Can I? Yes. Okay. And you can see these ringing artifacts all over the place. You can see some... Where is it? There. This area right here has some step artifacts, but the rest of the print has some pretty obscene ringing. And you know, it's just... It is personal preference to a certain extent. Whether you mind that ringing or not, And depending on that, you can tune your accelerations up or down and just, play around with it. It is trial and error, as much as I don't want it to be trial and error, but that's just how it works. That's how you get your best results. And what you can usually do is you can usually set your accelerations quite high if your slicer supports it. I think in Simplify 3D you can do it with a post-processing script. Cura 2 supports it out of the box, and Slick 3R supports it out of the box. So you can set your accelerations quite high for infill, for solid infill usually too, for like the inner perimeters, the inner shell, and then for the outer shell you drop it way down, and that's going to still print fast. It's still going to give you prints that complete fast if there's a lot of detail in there, but you're not going to get as much ringing on the outside. So that's a nice way to cheat. Usually for most of my printers, whether it's Ultimaker, BCN, i3, they're all pretty, the motion system stiffness wise is pretty similar on all of those. It's usually around 2000 to 3000 millimeters per second squared for the general print. Then you drop it down to maybe like 500 for the external perimeters. And that is slicer settings. That is what you set in your slicer software. What you set in the firmware is just the defaults. It's the maximums and defaults. So if your slicer doesn't tell the printer any overrides for that, it just uses those settings you hard coded in there, or you can still configure them and write them to EEPROM. So it uses those as a backup, but really you should be controlling them through your slicer. Yes, it is trial and error. I'm sorry. All right, hope that answers that. Let's see. I actually didn't have the time to look through these questions before, so let's just see what they are. Chris Petit is asking, so I switched my Delta Electronics to an Arduino Duo with RADs and RAPS 128 stepper drivers. I assume those are Trinamic drivers, because 128, not a lot of other drivers do 128. In combination with 400 steps NEMA 17 motors, and completely got rid of the moire you typically see on square prints. Can you explain a bit about why this happens? It's an improvement, but I want to understand why you have more moire with lower bit controllers and stuff. So that is actually this exact thing right here that he's talking about, this pattern. This is just when one stepper motor, okay, let's look at this. This was printed like that, basically. So what would that be? Let's say that is the y-axis. So this is the x-axis, my thumb over here. That's the x-axis. So the motor in the x direction on this surface didn't move a whole lot. The one in the y direction moved continuously, because it just, it continuously moves that way, but this direction didn't move a lot. So you see the individual steps where it goes clock, basically. That's how it looks if you would amplify the exact things that the controller is doing. And that is, this sort of stuff, stepper artifacting. What plays into this is your native resolution of your stepper motors. That is the 400 steps per revolution, which just means if you don't have any microstepping, which is I guess a cheating way to do it, to increase the resolution of your motor. If you don't have any microstepping, your motor is going to be much finer. So this pattern right here that you see, this is going to be twice as fine, which means you're probably not going to see it. The other thing, since he's using RAPS 128, again, I assume that is a Trinamic driver, is the microstepping itself. So when you have your motor's physical steps per resolution, let's just say this is the motor shaft. Let's say it's very coarse, so it does 1 step, 2 step, 3 step, 4 step. Let's say that's 4 steps per revolution. So 1 step would be a 90-degree turn. That is the mechanical electrical setup of the motor itself, and those are basically the only guaranteed positions that are there. But then what the stepper driver can do is it can play with the currents that it sends to each of the coils. There are 2 pairs of coils in here, and it can basically try to move it just a little bit, so it doesn't go from full current on to full current off on one coil. extreme case, usually it's like 71% on one, and yeah, details. But it can try to like dither. Dither, is that the right word? Yeah, I guess. It can try to dither between those two native positions. Some drivers are much better than this than others, and some motor and driver combinations are, just leagues, to a different combination. So this is the DRV-8225 Texas Instruments driver. These tend to have that exact effect, where the driver will try to do those finer steps to the next position, but what it actually does is it goes like so it doesn't have that smooth motion across the full range. So it's essentially like you're not using micro-stepping at all. You're not getting the full benefits. Trinamic drivers, on the other hand, are pretty good with that. So they actually give you, well, maybe not full 128 steps, but they actually give you a finer resolution between two native steps. That's what's going on there, basically. It's a combination of many things. And of course, if you go from a standard setup with, TI drivers plus, or Pololo drivers plus some sort of motor that maybe doesn't match them, to 400 steps per rotation motors and the Trinamic drivers, you're going from one extreme to the other. So yeah, that is what you'd see there. I'm thinking that is what he's asking about here, and I hope that answers it. So next up, Ulrich is asking the salt method of getting PLA prints to stick to glass. Have I tried it? Do I have an opinion about it? I do not. So far, I've mostly used purpose-made adhesives, maybe blue tape. I'm not a huge fan of that stuff, but anything that is made for sticking PLA to a smooth surface, I've used those for the most part because I know those work. And there are a few, tricks or household methods, like sugar water supposedly works pretty well. Salt works pretty well supposedly. I mean, some hairsprays you can use. I've always found that hard to reproduce because you have to like get the ratios exactly right and code it in exactly the right way. So I've not really tried that yet, but I do want to try it out in the future. 3D Printing Meathead is asking, how does interpolation work? I don't think I can actually explain that in full detail right here, but if you want to get the full serving of information, open up the Trinamic TMC 2100, basically TMC 2100 datasheet, and it's going to explain in full. It's going to give you nice graphs and everything, or just Google microstepping. That's going to explain it pretty well too, because it is a pretty involved topic. And that is the interpolation on the motor, on the physical motor steps there. Mark is saying, sorry, I cannot make the catch up. It will be 3 a.m. in the morning here. Well, we have recording, so that's fine. Can you do a walkthrough how to reset the bed leveling screws on an i3 clone if you have? I have the Maker Select 3D. On one side of the bed, the screws have been left out as much as they can and have very little adjustment left. Is there a way to tighten down all the leveling screws and then reduce the Z-exit limit screw to get the Z to home at a lower point, thus resetting things so I can have more room to work with the leveling screws? Well, of course you can do that. Do I have a printer that uses leveling screws is the question right now. I guess I could pull over the Dynamo 3D, that's what it's called. But basically, the Ultimaker also has leveling screws, even though it doesn't need them. So what you can do if you have like the 4 screws on the corners of your bed. I don't have one that uses those. If you have a printer that uses those 4 screws on the corners of the bed, yeah, what I like to do is actually with auto leveling, I just snug them down and let the software do the rest. But the process you can do to reset something like that is you tighten them down all the way. Then you get your nozzle as close as you can to the bed. You move it around until you find the one corner that is the highest. Reset your end stop, your Z-axis end stop for that, and then adjust the other 2 or 3 adjustment points to match that height. So yeah, that is what I'd recommend there. It shouldn't be that hard. So yeah, snug them up as much as you can and then work off of the highest one. So let's see, forums. I guess this one is done. Let's see. Okay, 2 of 8. Hoping that's not page 2 of 8. How's my CPU doing? Firefox, what are you doing? Okay, that should be everything. Let's start with Andrea Munigato. Tom, thanks for your fantastic work. Well, thank you for supporting me. I've built a big Delta printer, but when printing stuff, I'm encountering an extruder speed limit. From your experience, what the extrusion speed limit for a Teflon lined hardened with a 0.4 nozzle? Can I mount the volcano heat block with my Teflon heat break to increase the maximum extrusion flow? Okay, so that's a few things. So Delta doesn't really matter. Encountering an extruder speed limit, that can actually be a few different things. So that can be the actual extruder not being able to push hard enough because the motor's skipping or something. But I lost my okay. Sorry, reset. It can be the extruder with the motor skipping. It can be the gear grinding because you don't have enough tension on there, or the other thing can be that it's the hot end that has too much friction down its geometry basically. He or she, Andrea, might be male or female, is saying it is a Teflon lined hot end. Typically a Teflon lined hot end, that's going to be either an E3D Light 6 or one of the E3D improved Chinese V6 clones. And those do tend to have a lot of friction because just the geometry usually doesn't match up that well. So if that is your limiting factor, maybe try a different hot end. But yeah, what you can also do is you can increase the temperature. That's always something that helps, because as you push filament faster through a hot end, it gets less and less time to soak up the temperature from the heater block and the nozzle. So the faster you go, usually, when I print at like 50 or 100% faster on my machines, I usually bump up the temperature by 10 or 15 degrees. That's just to compensate for the decreased time the filament has to heat up. So that is something you can use to compensate for it. The other thing is, of course, you can tweak your extruder. You can give it more current. You can give the stepper motor more current. That's basically it. You can use a better tooth profile if the tooth profile is slipping. You can upgrade to something like a Bondtech or a geared extruder. Again, some of the Bondtechs are geared. Or the E3D Titan Aero, or Titan, the classic one, is also a geared extruder. That's also a good choice. Or just a classic Wades. I have a Wades somewhere around here. Yes. That comes with everything. Cool. So this guy, even for 1.75 millimeter filament, that is going to give you a ton of speed and a ton of traction, because the motor doesn't have to work as hard. Because this is 1 to 8. It's pretty heavily geared down. But yeah, that's going to help the extruder put more force onto the filament as well. Also, I'm assuming it's 1.75 millimeters Andrea is using. So if you're using 3 millimeter, that's going to require a whole lot more force again. So 1.75 if you can. And now to get to the core of the question. What is the extrusion speed limit for a Teflon lined hot end with a 0.4 nozzle? So how do you define speed? You could define it in like linear filament feed per second or per millimeter per second or per minute. So you could just take the filament and how how fast it is being fed in, and reference that number. However, that usually doesn't give you a lot of real world reference. So what I've found usually is with a regular nozzle, an E3D-V6, which is an all-metal one, not a Teflon line, but they should be pretty similar. And let's say thicker layers, let's give it a bit of a handicap there and say 0.3 or 0.35 millimeter layers. At around 100 millimeters per second, you are going to hit that wall of either the extruder is not going to be able to keep up, the motor is going to skip, it's going to grind, something along those lines. So yeah, with thicker layers, less than 100 millimeters a second. The other thing, even on a delta, if you go over like 100 or 120, 150 millimeters a second, that is nozzle speed, that is the speed you set in your slicer. If you go above that, usually you're going to run into some other issue. If you're using an 8-bit board, you're going to run into processing speed, processing power limits. If you're using, well, any printer, even if it's a Delta, you are going to see some increased ringing. You are going to see some issues where the extruder might be able to keep up, but at the beginning and the end of the extrusion line, where it speeds up, it ramps up its speed, then it goes at a constant speed, and then it slows down again. That entire extrusion line is not going to be a constant width, so it might have more filament at the beginning and at the end, and in the center it might have a bit less, which doesn't make for very strong prints or aesthetically pleasing prints even. So in general, I just say stay under 100 millimeters a second. And the other thing is, you are also, running into acceleration limits above like 100 millimeters a second or so, where you have diminishing returns. You can set the speed higher, but your print is going to spend most of its time just accelerating, ramping up and ramping down its speed. You're not going to see much of a print time decrease if you set the speed much higher. And can you mount the Volcano heat block with a Teflon heat break? Depends on how your E3D-V6 clone looks. I can't really make a general answer there, but probably. I'd say probably. Okay, question from Chad. D7 on the desk. Yes, that is today. After the stream, I'm going to eat something and then set up for the unboxing here. I'm hoping it goes smoothly. I don't want to stay up till 2 a.m. or something, but yeah, that's planned for later today. Right, let's see. How about doing a Patreon design and build more of an elegant 3D printer? The Prusa i3 clone was quite amazing for the cost. Maybe a frame from 4040 extrusion, much different than 2020, and tried to dual head or even swapping like CNC mills and more electronics controller out there now with wouldn't be cheap. Yeah, yeah, I do want to do more builds. It's just so much to do. I'm hoping with the editor, I'll have to see how much that actually takes off my shoulders, or if it keeps adding more overhead. I'm hoping with the external video editor, I can finally get working on my backlog of all the companies that sent me stuff, and now I'm like, hey, when are you making a video about it? So I'm hoping I can work through those. And get those out of the way, and we'll see. I could like use 3 employees at this point. But yeah, I want to do more builds like the hang print. I've been saying I want to build that for 2 or 3 months now. And I do want to print. I do want to build other printers as well, because it's good fun. It's a good project. Yeah, want to do more of it. What was there? One more question from Chad from 3D Printing Meathead that I wanted to answer. So he's asking again about the micro stepping. What is the difference between 16 steps with interpolation, so 16 times micro stepping, and just higher steps? So I think I actually did make an own episode about that, explaining how stepper motors and drivers work. But to break it down, a 200 steps per revolution stepper motor versus a 400 steps per revolution motor is going to give you twice the physical steps, no matter what your driver does, no matter if its micro-stepping sucks, whether it's inaccurate or whether it's perfect. It's just going to give you twice the resolution guaranteed. It's also going to limit your maximum speed. That's its trade-off, but usually it doesn't, the gain you get in resolution usually is more important than your maximum speed you might be losing. So, 400 steps per revolution motor just gives you a guaranteed, it's always going to work no matter your stepper driver. It's just going to give you twice the resolution in any case. Okay. Oh, that's a long one. Okay. During one of the Dolly live streams, you started a train of thought about why you prefer not to use ATX power supplies for 3D printers these days. However, a distraction resulted in that thought going unfinished. Yeah, as it often does. Would be great to hear the end of that thought on why ATX power supplies might not be good for 3D printers. On the surface, they seem particularly attractive since they already have the AC nicely isolated and are already available in relatively high capacities. With laptop-style power supplies, possible multiple be an interesting alternative. If mains wiring were avoidable, I think a lot more people would be inclined to build their own kits. And that is a different one. Okay, so let's try and answer that. I do have a big ATX supply somewhere around here. Might be... Yeah, okay, but I can't really get to that. There's stuff on top of it. Whatever, let's get it out. ATX supply, okay. So this is the one that I used in my big Mendel 90. This is a older one, a site. I have no idea how you pronounce that. But that's what it is. A Churiki 280 plus silver, which means it has good efficiency, 850 watts. So this is quite a beefy power supply. Still fairly compact. I think it was like $70 or so. It did cost a bit. It wasn't dirt cheap, but yeah, it has good efficiency. I kind of wanted that. So, ATX power supplies. Why do I kind of not like using them? Let's start with why they would be a good choice. So, if you look at this plug, this is your regular your regular ATX 20-pin plus 4-pin plug, and there are a number of different cool features on here. So you get 20 pins. Yellow is 12 volts, red is 5 volt, and orange is 3.3. So you get a whole bunch of different ones. You also get a few negative voltages, which you on a PC usually is used for audio, but in today's setups isn't used at all. How can we get this focused? Something along those. Okay. So cool features. Actually, both on this side. You have you have the green one. I believe it's the green one. I've not used these for a while. The green one is an on-off. It's a soft on-off, which means you can hook this up to your Arduino and turn on or off the entire power supply. So the entirety of the high performance parts of this power supply from an Arduino, which means you can turn it off through Octoprint, for example, and just have have the printer pretty hard shut down, or have a pretty hard shutdown for your entire printer, so everything is disconnected from 12 volts from the high amperage lines. That is extremely cool. It saves power and it's a safety feature. The other thing that is extremely cool about these is you have the purple, I believe it's the purple line, but the purple line is 5 volt standby, which means this is going to supply 5 volts of it's going to be a 5 volt supply with around, between 500 milliamps and 2 amps. So this is going to be enough to power a Raspberry Pi, the Arduino, whatever else you power, without powering up say, without powering up the rest of the power supply. So you can use that basically as an always-on 5-volt supply. Of course, you could also just use a small phone charger, plug it in, and use that as USB. But this has that exact feature built in that you can run something like a Raspberry Pi directly from it. Now, the problem I usually have with PC power supplies is, first of all, I don't want to hack them up. This is a whole bunch of connectors on here. I don't know, I guess you could run like 8 graphics cards with this and just as many optical or hard drives. I don't want to hack this up because I like to buy decent power supplies that I could use in like a PC. If you buy one specifically for a 3D printer, that's going to make stuff a lot easier because you can just cut these and get at the wires themselves. Otherwise, you're going to have to use something that fits in these plugs, either some sort of hack job with like copper wire, or get the proper connectors. The other problem that a lot of PC power supplies have is that they are going to cause, or might cause, some unpredictable failures on your printer. I've had one situation where I had an ATX power supply hooked up to a printer, and just at random times it would just stop. The entire machine would just freeze. Hot end would still be heating. Hot end would still be, kept at a constant temperature, but the rest of the machine would just be dead, basically. And what it turned out to be was a feature that the cheaper power supplies have, which, buy a modular one instead, sure, if you want to spend big bucks on it. But the cheaper power supplies usually have what is called group regulation, which means this power supply in here is going to make 12 volts from your mains voltage, and then it's going to take that 12 volt and use like one regulation circuit to step it down to 5 and 3.3 volts. So, or the groups might be different. So often that would actually be what I just explained would work for us. But if it's like 5 plus 12 volts, what might happen is if you're only drawing current from 12 volts, which you would if you have a heated bed and hot ends and fans and that sort of stuff hooked up to 12 volts, as that load increases, the power supply is actually going to regulate it's going to try to compensate for any voltage drops on the output circuit. So it actually increases, this is simplified terms here, it increases how much power it puts out, or how much voltage it tries to achieve on the 12 volt lines, and it bumps up its output voltage. You're still going to get perfect 12 volts here, but internally it steps it up. However, what's happening is that it also tries to get you, because they're regulated as a group, increasing that output power on 12 volt also increases the output voltage on 5 volt. So what sometimes happens is if you put an oscilloscope or a multimeter on 12 and 5 volts and start drawing power from 12 volts, you'll see 5 volt also starting to rise in voltage, which might be able to damage components in some rare cases, but worst of all, it might cause some hiccups in the power supply where it kind of goes into a shutdown mode, because it detects that it's putting out too much voltage on 5 volt. It goes into this shutdown mode, then the printer kind of hiccups, it stops drawing power for a second, it does weird stuff, and you never know which ATX power supply is gonna work for you, and you don't know which one is not gonna work for you. So it is a big question mark in the entire equation of your 3D printer, which is already challenging enough, I think. So definitely something an advanced user might look into using one of these, but for especially, okay, here's the other thing. An advanced user with the shutdown need and maybe the 5 volt standby feature, but the problem is these are still also 12 volts, so they're going to need to output a ton of current to satisfy something like a 600 watt heater PCB. So let's see what this one does. So it has two 12-volt rails. You can see these right here. That's 12-volt 1 and 12-volt 2. One is 65 amps, the other is 35 amps. And those currents, 65 amps, that is a ton of current. You're going to need huge wires. You're going to need a huge switching load to be able to switch that, to make use of the high capacity power supply in here. And for me personally, just going with mains voltage and you know, being careful to stick to those common safety rules, to common sense, is the better way to go about it. Or if you have to, get one of the small integrated ones like this, or larger ones, just the brick type LED power supplies, and go with 24 volt. Go with a 24 volt system. You're much more flexible with 24 volts than you are with any sort of ATX 12 volt supply. Yeah, I'm hoping that answers that. Plus, like the brick type, the LED power supplies aren't that much more expensive, if at all, than an ATX power supply that, again, doesn't have group regulation. That's going to work for a 3D printer. And you know, the brick types, they might, if you buy the super cheap ones, they might fail. But that's much more predictable. They're not going to hiccup. They're not going to give you more issues that are super hard to diagnose. Okay, I'm hoping that answers that in the right amount of detail. Similar to Mark's question about a more elegant printer. Premium self-built printer. Okay. I feel like many commercial printers are not fundamentally different designs. Yeah. So a commentary on that topic, on why a lot of the printers are the same, is because it works and there is little need to redesign stuff. So that sort of keeps people from innovating, and there's not really a need to do anything differently than an i3 or an Ultimaker or whatever. It works well enough. It doesn't work perfectly, but it works well enough. The thing about what a premium self-built printer might look like is it doesn't look like there's, like, people are interested in that. People are interested in ANET A8s, which are $180 shipped. People are interested in TiVo machines. People are interested in 1HOW machines, which it's all, you know, it's rock bottom. It doesn't get any cheaper than those. That's what people are interested in. Like doing a premium build, I'm not sure a lot of people would care about that. That being said, it's not going to be that much more compared to the Dolly, which was rock bottom again. It is going to be a bit more expensive. It's probably going to be like a factor of 3 if you're using like nice MGN9 rails, clones, and maybe electronics that are a bit more reliable. It's probably going to be in the $500, $600 range. You can build a really nice printer. You can build a really solid, sturdy, well-made 3D printer for that sort of money. It's just, hey, what do you do? Do you build one of those, or do you buy 3 cheapo ready-made ones? And most people will buy 1 cheap ready-made one. But it's definitely possible. But it is rather low on my priority because it's low on a lot of people's priority list out there. Panicut rearm process dynamics trams, will it work? Driver control, which might need to modify the smoothie where. So I have it trams here. I don't know about the Panicut rearm that well. I'm thinking that's just an Arduino sized board with an ARM processor, so with a 32-bit processor. I feel like it might work. I think it should work. The trams is still 5 and 3.3 volt. That might be the only thing. But my guess would be it would work. 32-bit plus trams might work. Or do it Wi-Fi. Big Philzing is bringing that up. Or just go with the do it Wi-Fi. That's exactly what you're looking for there. Have I had time to experiment with it? No. It's I can show you my Trello schedule. I've been scheduling out stuff. I keep saying it's coming up. It is coming up sometime. Hopefully within the next 4 weeks. Stopping just before printing. Is that likely a problem with Cura SD card? Okay. From chat, let's see if I can. This one. Related. I've started having problems with my printer stopping just before finishing, or simply not homing and cooling after finishing. Is that likely a problem with Cura SD cards or the printer? It could be either. It's probably not a problem with Cura. Cura does put out really good G code, or at least reproducible G code. That sort of stuff doesn't look like it's, or it doesn't sound like it's a slicer issue. SD cards, maybe, but I've never had a problem with SD cards causing any sort of issues before. Either it works or it doesn't. It doesn't like half work. Or the printers. So one thing I've actually had a ton of issues with is Marlin configurations. If you're using an 8-bit board, if you're using Marlin on an 8-bit board, you really have to pay attention to your configuration. I've had issues with a machine where it just did some random stuff. And what it turned out to be was that I copy pasted the configuration of an old Marlin into a new Marlin version, and it kind of didn't have one or two configuration options, or they were formatted differently, and nothing threw an error. Like the compilation went through, the printer booted up and printed and it worked perfectly, but those two missing configuration options caused some internal bug that just caused the printer to completely mess up. So that would be something that I try. And also check your power supply and grounding, make sure that is all solid and you don't have like loose wiring, etc. Everybody's loving their dude Wi-Fi's. I want to love it too. It looks like a great board. And I guess that's going to be the last one. We're at 45 minutes. That is good. Is there a reason not to use a Volcano? I think length hardened for smaller nozzle diameters. That's why my printer Hatchback Alpha came with, but I had a super hard time finding steel nozzles that were both long and had a 0.4mm output. Not sure if Volcano implies both length and output diameter or just one part. So you can get the Volcano, so the genuine Volcano, the longer heater block. That is only the block. That is just the longer block plus the special set of nozzles, but the nozzles are independent of the block. Volcano basically just specifies that it's a longer heater zone for E3D at least. Typically you're going to see larger nozzles. You're going to see 0.6, 0.8 and higher than that, but you can also use it with a 0.4. What I found might be there's some discussion going on about how much truth there is to it, but what I saw was that the longer heater block tends to ooze more than the shorter one. I have a feeling that might not be because of the geometry, because it's just a longer heater zone. I have a feeling it might be because the filament gets more time to heat. So yeah, I think a Volcano with a bit of a lower temperature than you'd use on the short heater block might work just as well as the short hardened. But that's just my 2 cents. That being said, I'm perfectly happy with the regular sized heater blocks on most stuff, except when you're printing really fast. But again, we talked about that. You might run into other issues, mechanical resonances, processing power limits, etc. if you try to bump up the speed too much. Usually the regular one is fine, but Volcano, I just tend to use it for larger nozzles that just aren't going to work on a short block. But the other way around, long heater zone and a thin nozzle might actually work pretty well. Drop the temperature a bit and you should be good. What is my... How do I do this? There. What is my recommendation for an easy part release build plate material for TPU like NinjaFlex? Any cool tips printing TPU? Any cool tips on printing TPU? I do have a video on that on the original NinjaFlex. If I had like someone who does that stuff live, I'd say, hey, look at this annotation up here, this info card. There's going to be a link, but I do have a video on what you should keep an eye out for. The most important things are good or a tight filament path from the extruder gears all the way into the hot end. Preferably direct drive, so no Bowden tube in between that, but the extruder directly on top of the hot end. And make sure just the gears are really well encased and there's a straight, smooth bore all the way down into the hot ends, Peter zone. That is one of the most important things. Other than that, it go a bit slower. Maybe that's always a good tip. Go a bit slower is like the universal 3D printing tip. Just lower your speeds by 30% and your prints are always going to come out better. What else? Good bed release. Definitely don't print on glass and do not print on PI. That's going to rip up your glass and PI and or PI because it fuses like really well. What I found to work well for flexibles is Magic Goo. Let me show you. There you go, Magic Goo. That stuff. It's like it's a disgusting fluid, but it works. It's like a really thick molasses-like stuff you smear on, and it comes off with the print. Works great for TPU. Sticks to it pretty well, and then after the print, it comes off as one piece from your build plate. So that's good. Or glue stick. Glue stick is also that nice happy medium for TPU where it doesn't really bond to it, but it sticks well enough. TPU doesn't need to stick that well to your build plate because it doesn't warp. It can't produce any forces. So yeah, glue stick usually also works pretty well. Okay. You should make t-shirts with that print slowly slogan. Yeah, maybe in the next wave. Yeah, I'll try to get those. Where did I have it upstairs? Okay, I'll try to get the Tom's 3D t-shirt out sometime soon. I'm gonna send out the surveys for what you guys want, as in which design, if you want filament, if you want mugs. I'm just waiting for the filament to get finished. Actually, dust filament should make some today. First samples. I'll probably have a look at that when I get back from FabCon 3D next week. That's going to be Tuesday, Wednesday, Thursday. And yeah, that's going to be fun. I'm really looking forward to that filament. And t-shirts going out to everyone, and stickers and stuff. It's going to be good fun. So again, thank you for supporting me on Patreon. That makes a huge difference. It really does. I keep saying that, but it's awesome. Thank you guys. Have a good evening, and if you have a minute of patience, I'll set up the live stream for the One How Duplicator 7 right now, and do that in a bit. I don't know, an hour, 1.5 hours. Let's see. Okay. Thanks for stopping by, and see you later. Cheers. Do you want to stop the stream? Yes, I do.